Let's start with the point A. The point A is 40 mm above HP and 25 mm in front of VP. So above HP by distance 40 and 25 in front. So this is our point A. In front of VP, distance is 25 and above HP distance is 40. Okay, now the object is located in first quadrant, so we know that the front view is going to appear above XY line, top view is going to appear below XY line. Okay, now in this direction look for the front view, and in this direction top view. So when you draw it is going to be projected on this vertical plane. The point is 40 mm above HP, so this front view appearing on this vertical plane will be at a distance of 40 mm above XY line. So if you consider this one XY line at a distance of 40 mm, you will get a dash denoted by front view. Let me draw a projector of the A on that point. You will get the top view. So when you look for the top view, it will be projected on this horizontal plane. Point is 25 mm in front of VP. So from XY at a distance of 25, you will get this top view. Now as it is appearing on horizontal plane, I need to rotate it in clockwise direction by 90 degree. So the point that was appearing at a distance of 25 in front of XY will actually be projected at 25 mm below XY. So at a distance of 25, you will get the top view. So this is front view, this is top view. This distance is going to be 40 and this distance is going to be 25. So this would be the solution for the point A. Now let's consider point B. Point B is in HP. So the point is located on this horizontal plane. It might be in front of vertical plane, in behind vertical plane. So another reference is 20 behind vertical plane. So point is located over here. This is our point B. It is in HP and 25 mm behind VP. Okay, now if you draw its solution, this is our XY line. When you look for the front view is going to be projected on vertical plane, and when you bring it on the vertical plane, it actually overlaps with the XY. So on XY itself, you will get the front view of point B denoted by B dash. Now through this projector, I am going to draw its top view. Now for the top view, in this direction, the point is on HP itself. So at the same place, I am going to get the top view. And for visibility purpose, I need to rotate it in clockwise direction by 90 degree. So it will get shifted over here. That is going to be 25 mm above XY line, and this is going to be a top view. So above XY line at a distance of 25, you will get its top view. Next, point C. Point C is in VP and 40 above HP. So point is in vertical plane. So on this vertical plane the point is going to be located somewhere, and the another reference is it is above this. Now when you draw its solution front view, it will appear where point is located. It is on VP itself. So this is going to be position of the front view at a distance of 40 above XY line. So this is going to be a C dash. On this projector we are going to look at top view. When you draw its top view, we need to project it on the horizontal plane. So in this case, when you project its top view XY line, so on XY line itself you will get its top view. The distance of front view to be shown, this distance is 40. So this would be the solution for point C. Next point D, it is 25 below HP and 25 behind VP. So the point is located over here. This is point D. It is 25 behind VP and it is 25 below HP. So this is in third quadrant. Now when you project its front view, it will get projected over here. This is your front view. Distance from XY is going to be 25. So below XY line at a distance of 25 you will get a D dash, and on the same projector and you draw its top view, the top view will be projected over here. Point is 25 from vertical plane, so this top view will be at a distance of 25 from XY, and as it is appearing on HP you need to rotate it in a clockwise direction by 90 degree. So actual top view will get shifted above XY line by a distance of 25. So this is going to be top view. This distance is 25 and this distance is also 25. Next point is E. Point E is 15 above HP. So above HP by distance of 15. So let's see if it is in first quadrant or second quadrant. Another reference is 40 behind VP. So this is point E. It is 40 behind VP and 15 above HP. So it is located in second quadrant. So we know that front view, top view both are going to be overlapped above XY line. So this is XY. In solution, let's say this is XY line. So for front view, it will be projected over here. This is going to be a front view, distance above XY 15. So this is E dash. The distance from XY line is 15. Okay, now let's look for the top view. It will be projected on the horizontal plane. Distance from XY will be equivalent to distance from vertical plane, so 40, and for visibility I need to rotate it in clockwise direction by 90 degree. So actual top view will get shifted over here, and this distance will be equivalent to distance from xy, that is 40. So on the same line or same projector of E dash, at a distance of 40 you will get its top view. This distance is going to be 40. Next, point F, it is 40 mm below HP, so either third or fourth quadrant. Another reference is 25 in front of VP, so below HP in front VP, it is part of fourth quadrant. Let's look at the point F, 40 mm below HP and 25 mm in front of VP. Sorry, not front view, it is point F. This distance is 40 mm below HP and 25 mm in front of VP. Now let's draw its projections. XY line, front view will be projected on VP, below HP 40, so front view will appear below XY at a distance of 40. So this is F dash. This distance is going to be 40. Now let's draw its top view. It will be projected on this horizontal plane over here in front of VP 25, so it will be 25 in front of XY or 25 from XY, and as it is appearing on HP, I'll have to rotate it in clockwise by 90 degree, so that will be 25 mm below XY, and that is our top view. So at a distance of 25 below XY, I will get the top view. So this is front view and this is top view. Last point, point G is in HP. So it is on this horizontal plane. It might be anywhere in first quadrant, second quadrant, and in VP also. So the point to be on HP as well as VP simultaneously, the point must be located on intersection of HP and VP. So this is the position where point G is located. Now when you draw its front view and top view, this is our XY line. When you look for its front view, it is on XY line, so this is G dash. Similarly, when you look for the top view, it is on XY line itself. So in this case, the point the front view as well as top view of the point will be located on XY itself. Okay, we are going to solve this example F. A point Q is situated in first quadrant. It is 40 mm above HP, 30 mm in front of VP. Draw its projections and find its shortest distance from intersection of HP and VP and auxiliary plane. Okay. Now this is the point. This is the point Q. It is 40 mm above HP, 30 mm in front of VP, and we have been asked to find shortest distance from VP. Solve this example. Let's say this is XY line. its front view is going to appear 40 mm above h. So let's say this on the projector through Q, its top view will appear over here 30 mm from xy, and on rotation it will be 30 mm below xy. So over here you will get the its top view. Now to find its shortest distance from HP and VP intersection, that is from XY, let's consider this another reference plane x dash y dash. Now project this front view horizontally through this intersection. I'll draw one line, incline at 45 degree. Project this top view horizontally till this inclined line, and then project it vertically upward till it intersects the projection of front view. So this is going to be our side view. Now we need to connect it with the XY line, and we need to measure distance of this line. And once you get that distance, specify the distance in terms of millimeter, and that will be the solution. Okay, another example, G. A point P is 20 mm below HP and lies in the third quadrant. Its shortest distance from XY line is 40 mm. Draw its projections. So the point is in third quadrant. Its distance with respect to HP is given, but with respect to VP that distance is not given. Instead of that one, the shortest distance from XY line is given. So let's say this is horizontal plane, vertical plane, and this is intersection of those two XY. This is the third quadrant, below HP, behind VP. Now the distance with respect to HP is 20 mm below HP and 40 mm from XY. So below horizontal plane at a distance of 20 mm on this locus, you are going to get that point P, and the shortest distance from XY is 40. So if you take that 40 in a compass and have intersection, this distance has to be 40. This is going to be our point P. Okay, so this is for understanding, but in solution how you can do that, this is XY line. The point is over here, so its front view we can locate even when its position with respect to VP is not given. It is 20 mm below HP, so its front view can be located. So let's say this is P dash, and let's say that we have got at a distance of 20 mm. Okay, now to locate its top view, its position with respect to HP should be there, but that is not given, so we cannot locate its top view for time being. So let's say what we can do, I'll draw this another reference line x dash y dash. In this quadrant I'll draw this 45 degree line that I'm going to use to transfer the horizontal distance to vertical distance. I'll project this P horizontally. The short distance is 40, so that distance I'll take in a compass. I'll keep compass at the intersection of this auxiliary and main xy plane and have intersection over here. So this distance is 40. Okay, so this is basically a side view. Now I'll project this point vertically upward on this 45-degree incline line, and this intersection I'll transfer horizontally. Now when that horizontal projection intersects the projector passing through P dash, this is going to be our top view. Okay, now I'll project this point horizontally, and we already have drawn this vertical projector through P dash, so intersection of those two you will get the top view, and this distance we need to find. This x is going to be distance of the point P from the vertical plane. So this would be the solution.